All right, this one gives us a graph that has three different things going on. Let's see, one of our graphs looks like this and looks a lot like a cubic function. You think of x cubed as a similar shape to its graph. Then we've got one that looks something like this. And that one looks very similar to x squared. And finally, there's a linear function. It's right about in there. So that looks closest to y equals x, which looks like that. All right, our task in this question is to figure out which one of these would be the function, which would be its derivative, and which would be its second derivative. Okay, well, if you think about the power rule when we do derivatives, and each time you take the derivative, you lower the exponent by 1, means that the function is going to be the one with the biggest exponent. So this could be my function. And to make this match up a little bit closer to this actual graph, instead of thinking of x cubed, it's probably x cubed minus 1. Or that would be very, very close to what they've got there. And notice if I took the derivative of this, this would be 3x squared, which is very similar to this one. So I mean, compare x squared to 3x squared. It's just a little skinnier. So then this should be its derivative. And if this was 3x squared, imagine if we took the derivative of this and brought the power down, lowered the power by 1, maybe their linear function is actually 6x. So if I graphed 6x instead of x, it's just going to have a steeper slope, and that's pretty close to what they have. So I would say all of that seems to be matching up. So here's f of x, here's its derivative, and the linear function there looks to be its second derivative.